Okay, let's look at 657. This is a stadium truss that has a loading as shown, and we're supposed to determine the force of members AB. So this one, come on, you can do it. This one, AG, this one, and this one. So hopefully that screams at you, hey, I should use a method of sections, because if I pass it right through here, then I'm going to have my three unknowns, and that's all I have to solve for, and I am good to go. So the question is, do I do this? Do I take this section, or do I take this section? Okay, so I'm going to say, what's the problem with this section on the left? The problem with the section on the left is we're going to have to figure out this unknown, sorry my arrows are terrible, also this and this. So now I have four unknowns. So it turns out I can solve for it by taking them as separate independent bodies, but I'm not going to. So instead I'm going to take this side. So let's draw the free body diagram. So the free body diagram looks like this. Well, that's actually not bad. Okay, it wasn't bad till there. So we'll say at this point it's the same. Watch this. Boom. Close enough. Okay, there we go. So there's my free body diagram. I have a force here of 1.8. I have a force here of 1.8. I have a force here of 0.9. What about this force right here? It's not on my free body diagram, so please don't add it. I got all those external forces. Now what did I cut through? I cut through a force here of Fg. I cut through a force here of Ag. And I cut through a force here of AB. Okay, so that is my free body diagram. So I got to trust that I did my free body diagram right and then stick with it. So don't add weird forces that aren't on there. Okay, so now, how am I going to do this? Well, there's certain places that make life kind of easier, if you will, right? This point right here, what's special about this point? This is point D. If you look at point D, what do you have? Well, FG passes through there and AB passes through there. So you get rid of two of the unknowns. What about this point, point G? Well, AG and FG pass through there, so you only have one unknown AB. What about this point right here? AB passes through it, but I still have two unknowns. It's doable. But what about this point right here? When we extend this up into here, this is point A. Well, two of the unknowns AB and AG go away. So there's just all sorts of places where you can take the moments to make life easier. So let's start with the sum of the moments at A equals 0. So the sum of the moments at A, so this point right here. So I have 1.8 times 12, this distance right here, right? Plus 1.8 times 12 plus 14. So I'm talking about this force right now, so plus this distance right here, plus 0.9 times 12 plus 14 plus 14. So now I'm talking this distance right here and this force here. Okay, so at A, AB passes through A, so that's not there. AG passes through A, so all I have left is this FG. So these ones that I drew go in that direction. FG is also going to go in that direction. So plus FG times the height from this height right here, which is given as 9. And that equals 0. So therefore, FG equals minus 11.6 kips. Okay, so negative just means that I drew it in the wrong direction. Doesn't mean I'm a bad person. It's fine. Just drew it in the wrong direction. So therefore, FG is equal to 11.6 in tension or compression. Well, I drew it in this direction, pulling away from that point. The only way it pulls away from a point is if it's in tension. So therefore, I drew it in tension, and I got a negative. So therefore, this is in compression kips. So FG is 11.6 in compression. Don't ever give me a negative answer. Just tell me tension or compression. Okay, so let's pick another point. So should we do it at, we did it at A. Should we do D? No, sorry, that's D. So let's do sum of my moments at D equals 0. Okay, fair enough. That's a sum. Totally looks like a sum symbol, right? Sum of my moments at D equals 0. So what do we have? We have 1.8 times 14 plus 1.8 times 28. So this force, they're going to make it go in that direction. FG passes through there, so that goes away. AB passes through there, so that goes away. So all I have left is AG. So AG has a Y and an X component. The X component is going to pass through there, so that goes away. and the y is going to make it go in the other direction, so therefore this is equal to AG in the y direction. Sorry, get rid of that. Boom. Try this again. AG in the y direction times the distance from here to here, which is 28. So therefore, AG in the y is equal to 2.7. Yay us, and it's positive. But I don't want the AG and the y, I want AG. And so I'm going to look at this triangle. So we're going to look at this triangle right here. This triangle. So let's draw that over here. We have a triangle here. This is 9. This distance is 12. So this works out to be 15. Totally looks like 15. So AG in the y is equal to AG times 9/15. So therefore, AG is equal to 4.5 kips. So tension or compression, well, I got a positive value, so I look at how I drew it, and I drew it in tension because it's pulling away, so therefore that's in tension. The positive tells me I drew it right, and I drew it in tension. Okay, boom, we got 2 of them. The last one is AB. So AB is simple, it's just mathematically a little more complicated. So where should we take AB? What if we do it at point G? Let's say, so I could do my sum of my forces in X and Y, I'd get the same answer. But I just feel like doing some of the moments. Sum of the moments at G equals 0. So at G, what do we have? This 1.8 passes through it, so that goes away. 1.8 times 14 plus 0.9 times 14, right? So those two, sorry, that's not 14, that's 28. 14 times 2, there we go. And we're taking it here at G, so AB now has an X component and a Y component. The Y component passes through G, so that's a non-thing. So the X component, so I just drew these two, let's get rid of these. These are going to go in this direction, and I have this drawn to go in that direction, so this is equal to AG in the X times from here to here, which we don't know, but we're going to have to figure that out. So let's look at this triangle. This big triangle, I'm going to come over here. This is a big triangle. Wow, let's try that again. This is a nice big triangle. Okay. So this distance is 9, this distance is 40, the 12 plus 14 plus 14. Turns out when you take the sum of the squares, this distance is 41. Okay, so we need to know how somewhere in between, at 28 in, how high is this distance right here? This is y. So I'm going to do similar triangles. So y is to 9 what 28 is to 40, right? So therefore y is equal to 28 over 40 times 9, which works out to be 6.3. You could figure out this angle theta, and you could do all the same things. You're going to get 6.3. So this is equal to AGX times 6.3. So therefore, did I call it? Yeah, it's AG and X. So therefore, I'm calling that AG, sorry, it's AB. Let's see. This is AB in the X. So therefore, AB in the X is equal to 8. But AB in the X, coming back to this triangle, is AB times 40 over 41. So therefore, AB is equal to 8 times 41 over 40, which is 8.2 kips. Okay, tension or compression, well, I got a positive number, therefore I drew it right, and I drew it away from the point, so therefore this is in tension. And boom, there you go. So there's your 3 answers. First one's in compression because I got a negative number and I drew it in tension. I tend to draw a lot of my things in tension just because I think it looks easier to do it. No, I really don't have a good reason. I just draw them in tension for whatever reason. And so if I get a negative number, it means opposite. So I got the first one's in compression and these other 2 are in tension. And you're good to go.